Alright, here's lesson 2.1, mathematical reasoning, lesson number 1. Inductive reasoning, conjectures, and counterexamples. So part 1, the circle shown has a center O and diameter AB. Use a protractor to measure angle ACB and record your answer. So here's a little protractor. So we're going to set this up like so. And it looks about 90 degrees. Okay, so it looks about 90 degrees. Mark any point D on the circumference of the circle. So let's choose over here point D. Connect D to A and B. So we draw two lines as shown. And let's use the protractor. Measure our angle. So it's pretty rough, but it looks, again, to be about 90 degrees. Okay, let's get the protractor out of the way. And we need to pick another point. So it says to do 3 points, but let's just do one more. So connect B to A, and use your protractor and measure it. Lo and behold, looks about 90 degrees. So what conclusion can you make? Well, the conclusion I would make is any angle on the circumference whose arms pass through the endpoints, sorry for the writing, endpoints of the diameter is 90 degrees. Alright. Bruno is investigating a fabric design for a new furniture he's making. The original design is based on a trapezoid. His first two complete sketches and third incomplete sketch are shown. So complete the third sketch. So the third sketch should look like, it's going to have two little trapezoids there, and there, and then two more on this side. Okay, complete the third sketch. So Bruno wondered how many new trapezoids would have to be added in the fifth sketch without drawing the sketch. Complete his table below to figure that out. So let's do the table. I'm just going to zoom in a little bit. So sketch number 1 had 2 new trapezoids. Sketch number 2 had 4 new trapezoids. Sketch number 3 had 8 new trapezoids. And sketch number 4 had, if we continue on, should be 16. Sketch number 5 should have 32. And sketch number 6 would be 64, if the pattern follows. Based on your conclusion, just going to delete that. Based on your conclusion, what can you make about the number of trapezoids added in the 10th sketch? So the 10th sketch would be 2 to the power of 10. Sketch number 1 was 2 to the power of 1. Sketch number 2 was 2 to the power of 2. 2 to the power of 3. 2 to the power of 4, etc. So it would follow that the 10th sketch should be 2 to the power of 10. Work that out on the calculator. That's actually 1,024 trapezoids. Okay, inductive reasoning. In the investigation on the previous page, we based our conclusion on the patterns and observations we made. This is an example of inductive reasoning. So based on the patterns that we looked at, we figured out what the next thing would be. Inductive reasoning is a type of reasoning in which we arrive at a conclusion or generalization, or educated guess based on experience, observations, or patterns. The conclusions to the investigations on the previous page are called conjectures. So conjecture is what you arrive at when you use inductive reasoning. The use of tables when determining conjectures, such as that in part 2 of the investigation, is strongly encouraged. So don't just try and figure it out in your head. Write stuff down. It's going to make it more clear. Conjectures may or may not be true. They might hold true for the first 5 steps, but might fall apart after that. So there's something else we're going to do, that we're going to actually have to prove our conjectures. So explain how you used inductive reasoning to arrive at a conjecture from part 1 of the investigation. So all the angles, oops, can't spell, all the angles measured 90, so every other angle, every other instance will be the same. Bruno used inductive reasoning to arrive at a conjecture from part 2 of the investigation. That was the trapezoid one, okay? And that was the number of new trapezoids doubled time, therefore, 3 dots is therefore, Bruno could extend the pattern. Alright, a counterexample is an example which shows that a conjecture is not true, and in fact, false. Katie and Perry were given the following number pattern by their teacher. Katie's task was to make a conclusion based only on the number pattern shown with no further investigation. Perry's task was to see if Katie's conjecture was correct or not. Katie wrote the following conclusion. When an even number is squared and 1 is added, the result is a prime number. So 2 squared plus 1 is 5, 4 squared plus 1 is 17, 6 squared plus 1 is 37. So it's holding true for all of these examples. So Katie's conclusion is a conjecture. I'm just going to write it underneath. Conjecture based on inductive reasoning. Perry investigated Katie's conjecture further by using even numbers not shown. She correctly stated that Katie's conjecture is false. Determine a counterexample to show Katie's conjecture is false. So Katie's conjecture proved true for all these examples. What we need to do is find something that is false. So let's try 8. 8 squared plus 1 equals 65, which is not prime. So we followed the same pattern, but the answer we got didn't follow what Katie's conjecture was. So when a conjecture is shown to be false, it may be possible to revise the conjecture as illustrated in the next example. So Mick and Sue were discussing what conjecture could be made regarding the prime number pattern shown. They both agreed to the following conjecture. The sum of 2 prime numbers is an even number. Provide a counterexample which shows the conjecture is false. So 2 plus 3, they're both prime numbers, is equals 5, which is odd. So that holds true. Revise the conjecture so it holds true. Well, it can be as simple as saying the sum of 2 prime numbers, which are not 2, is an even number. is uneven. So make a conjecture based on the number pattern if the condition prime number was removed. And you could say the sum two prime numbers, sum of two odd numbers is even. Alright, class example 4. Jerome investigated the following number patterns. He noticed that all the patterns, 3 consecutive numbers, integers, were being added. Write 2 more number patterns following this, showing the sum of 3 consecutive integers. So let's use an easy one. 2 plus 3 plus 4 is going to equal 9. Well, let's go negative 1 plus 0 plus 1 is going to equal 0. You could even do more, 11 plus 12 plus 13, etc., etc. Use inductive reasoning to make a conjecture based on the sum of 3 consecutive integers. Well, look at the middle number in each of them. Okay, 2, 6, minus 5, minus 11. Multiply each one of those ones by 3. So 2 times 3 is equal to 6. 6 times 3 equals 18. 3 times minus 5 is negative 15. And negative 11 times 3 is equal to negative 33. So using inductive reasoning to make a conjecture. Well, my conjecture is the sum of 3 consecutive integers is equal to 3 times the middle integer. Inductive reasoning can be used to make conjectures, but cannot be used to determine if a conjecture is true. We can never be certain that the conjecture is true for every possible case. We know it only to be true for the cases we have investigated. So inductive reasoning is based on the information you're given. To prove a conjecture is true, we need to use logical or deductive reasoning, as we shall see in the next lesson. To prove that the conjecture is false, we need only find one counterexample. The conjectures in class example 3 and 4 are true and will be proved in the next lesson using deductive reasoning. So I'm going to leave class example 5 up to you guys. If you can get a graphing calculator and graph this with this window, if you need to know how to do that, come see me. After observing the screen, she made the conjecture y equals x to the x has a domain this. Show that her conjecture is not true by providing a counterexample. So I can go through this if you come find me. I have a few extra graphing calculators and you can try it.